All right, boys and girls, this lesson is kind of difficult simply because it's not what you're used to, okay? We're gonna be learning about proofs, and proofs are basically, it's like logical thinking, okay? If you're good at computer science, then you would understand proofs. If not, this is going to be difficult, but I'm gonna break it down for you guys. All right. I'm gonna do an everyday language example for you, okay? Let's just say I give you this idea. I'm gonna give you a statement, okay? There are dark clouds in the sky, okay? Dark clouds. Now, here's the deal. If I give you this statement that there are dark clouds in the sky, right? If you see dark clouds, then what do you guys think is gonna happen? I'm gonna say, well, then the floor is gonna be wet. Why in the world am I able to make this conclusion? Well, the reason being is because it was raining, right? And this is basically how logic works, right? You're given a statement, there are dark clouds in the air, and you're able to instantly make a conclusion, right? That the floor is going to be wet, and the reason why the floor is going to be wet is because it was raining, right? So this is basically if dark clouds, then the floor is going to be wet, and then this part, the reason is because it was raining. Literally, it's an if-then statement with a because, okay? And you're given this thing. That's literally it. Here's another example. These are not like professional examples, but it's just like to help you guys really understand this idea, okay? Let's just say if, like, you know, I walk into the barber shop, right? If I walk into the barber shop, right? And I, let's see, walk out. If I walk into a barber shop, right? Then I have a walk out with a haircut. What happened? Well, the reason why I'm walking out with a haircut was because I got a haircut, right? That's literally it. So literally, think about it, guys. Like, if like, there's no reason why somebody's walking in the barbershop without getting a haircut, right? So it makes sense. All these three things go hand in hand. If you walk into a barbershop, you're gonna walk out with shorter hair, right? Actually, it's like walk out with shorter hair, right? Why is it that you're walking out with shorter hair? Because you got a haircut. That's literally the general idea. Now, the question is, can we take this logic to, actual math, okay? Everything that you've been learning up to this point. So let's take a look at this. There's only three main ideas that you have to understand right now. It's midpoint, segment bisector, and angle bisector. And it comes down to you knowing the definition, right? Let's just say I tell you that B is the midpoint, right? B is midpoint. That's the idea that I'm giving to you, that the B is the midpoint. Well, if B is the midpoint, right? That implies one thing. This is literally in the middle of this entire line. Therefore, if B is the midpoint, then, right, reason number two is AB, the line of AB, is going to be congruent to the line of AC. Why is this the case? Because midpoint definition. By definition, the midpoint itself means it's literally in the middle. Therefore, this piece has to be equal to this piece, congruent. That's it. That's really the logic behind this. So it's interconnected, right? If you know that AB is congruent to AC, that it means, BC. If you know AB is congruent to BC, then you also know that B itself is the midpoint, okay? Let's do two more examples, this time with segment bisector, okay? If I tell you, right, that CD, right, bisects AB, line AB, there's only one logical conclusion. CD is the knife, is bisecting AB. Therefore, right, you know, and it's at point, let's just say E, right? At point E, if CD bisects AB at point E, you already know then that AE, right, is going to be congruent to EB. Why is that the case? Simply because of the segment bisector definition, right? Segment bisector definition. This bisector, right, means that it's going to be cutting this in half. The word bisector itself means it's going to be cutting it in half. Therefore, if this is half, that means this side has to be equal to this side. It's a 1-to-1 ratio, okay? Last piece right here, which is the angle bisector, right? Let's just say I tell you that angle ABD, right, is congruent, right, to angle DBC.
if this is what's originally given, then it's logical. The only way that these two, this could be equal to this, is if BD is what? If BD is the angle bisector, right? Line BD is angle bisector. That's it, right? And we know it's the angle bisector because of the angle bisector definition. Okay?